in mere decades. The particle description of reality was split into 17 parts, with only 3 considered responsible for matter: the up quark and the down quarks, which together form the protons and neutrons of any atom, and the orbiting electrons. All that we encounter in our day-to-day experience of the world, everything we've ever touched, tasted or heard, has been the result of nothing more than the interactions of these 3 point-like particles. A 4th particle, known as a neutrino, which, in contrast to its siblings, careens unaffected through the bodies and planet as carelessly as any truck careens through the slightest breeze, completes our lineup of the 4 matter particles. A model beyond the insights of any single great mind. One of our species' greatest ever achievements, which we quite modestly refer to as the Standard Model. These 4 particles, fundamental to matter, are known as the fermions, a pattern of 4, which nature, for reasons currently known only to herself, has repeated twice over in more exotic forms of matter. 2 sets of copies, each heavier than the last, making all in all 12 matter particles, all of which host some element of mass. The remaining 4 non-matter particles are called the bosons. These are those that make the whole machine of the universe go. Unique particles, each representative of one of the 3 known forces of the universe: weak nuclear, strong nuclear, and of course the electromagnetic force. And it is the particle representative of the electromagnetic force that we now refer to as the photon, the elusive particle of light that we have so longed to understand. But what of the ether? And so, here now, for its final bow, re-enters our wave perspective of reality. As our latest discoveries have revealed, these most fundamental elements of matter are not mere particles. As fundamentally, they are considered the excitation of fields that permeate the entire universe. For as the photon is an excitation of the electromagnetic field, so too is the electron an excitation of the electron field, the up quark an excitation of the up quark field, and so on. 17 fields, each known to interact with the others, all unified as one singular interlacing fabric relating to itself across the entire universe as it warps and stretches along the geometry of space-time. This is the picture presented to us in quantum field theory. An ocean of 17 fields which vibrate harmoniously, exciting one another into giving rise to the concentrations of energy that we appreciate as particles. Particles that appear to pop in and out of existence as they rise from and fall back into their parent field. The final field of the fantastic 17 was theorised in the 1960s in 3 separate peer-reviewed papers, all of which described aspects of a field which, in a very crude sense, dragged upon the other fields, thus giving rise to the phenomena of mass, specifically the mass found within those elementary particles. And so, how might an experimental physicist uncover such an invisible field? Well, they'd do as nature does, and excite the field into revealing its particle. By accelerating 2 particles as close to the speed of light as possible, and then smashing them into one another, physicists can cause the necessary intensity of waves. Because smashing particles inside a collider doesn't just send the particles' inner bits hurtling about the room, revealing their constituent parts. Instead, it sets high-energy vibrations of these fields into motion, temporarily bringing into existence new particles. Such a smash should, if the theory were correct, very briefly excite this hidden field into giving rise to its sibling particle, the hidden, fleeting boson. And in 2012, at the Large Hadron Collider at CERN in Geneva, physicists announced the discovery of this very boson, the Higgs boson, and thus the 17th field of the all-impressive Standard Model. But physicists know the battle is still not yet won, as they are all but sure that there are more fields out there waiting to be discovered, more fields that intermingle and play with all that we currently see and understand as physical reality. Still remain the fields that would explain the existence of gravity, dark matter, and the dark energy thought to be fueling the universe's growth. Nonetheless, here it is, our final frame. A picture where the flux of universal energies is understood as harmonically oscillating fields, permeating the entire universe and giving rise to light and physicality as we know it. But importantly, in respect of our own search into the ontological nature of reality, in the language of physicality at least, due to this flux, all is one. Because nowhere within our vast wealth of scientific discoveries have we ever discovered anything truly empty. The vacuum of empty space is instead full of vibrating energies, being and becoming always and everywhere. For space is not a thing we sit in. We are space. Every mode of energy, every being, every particle exists only in its relationship with other particles. And these relationships are the actuality of that space. Not but mere tendrils of connections, as between all beings, becomings, waves and particles, all spaces are full. Emptiness is full of itself, as I too might sound at times. Thus, all bodies existing upon this sea of relationships are in actuality a contiguous fluid whole, perhaps even to an infinite degree. And so this is where we have now come to sit, upon yet another of our shorelines of understanding, upon a flux proposed 2,500 years earlier by ancient thinkers and interpreted as everything from a void to a god to an interconnected dance of layers. Light, ether, matter, us and the heavens above, both beyond and within, are all but unique cross-sections of the same pulsating moment. And so, if this is modern science's current, though clearly unfinished, interpretation of the flux, where, if anywhere, can we now begin to place our contemporary ideas of consciousness? If you enjoyed that and you would like to watch the next part, I'm going to put the links below. Otherwise, the full 1 hour deep dive into the history of light is currently available on our homepage, so feel free to check that out. Otherwise, much love, and I hope you all have a wonderful, wonderful week. See you later.